Hi, today we're going to be talking about operations with radicals, and radicals are actually a fancy word of saying square roots. So we're going to be talking about square roots today. So there are actually two I can statements. One, I can add and subtract radicals with emphasis on square roots, and we're actually going to be multiplying and dividing radicals with an emphasis on square roots. So we're actually doing both. And so let's go ahead and get out a piece of paper. You're going to need something to go ahead and write on. And let's go ahead and go through this. So the steps for adding and subtracting. These are for adding and subtracting. So there will be steps for adding and subtracting, and then there will be different steps for multiplying and dividing. So kind of keep that in mind. So for adding and subtracting, we're going to simplify your radicals. Okay, we're going to talk about that. You cannot combine terms that do not have the same radical. Radicals are the numbers actually underneath the square root. They're called radicals. And rewrite your solution in simplest terms with the coefficient. And then when adding, subtracting radicals, you can only add and subtract the numbers in front of the like radicals. And then we do not change the radicand. All right, so radicals are all the square root kind of stuff. Kind of keep that in mind. And we're actually going to go ahead and walk through this. So here's example number 1. We have 3 square roots of 5 plus 2 square roots of 5. We're going to go ahead and see if we can go ahead. We have to look at the square roots first and see if we need to simplify them. So this is square root of 5. Is this simplified all the way down? Yes. Okay. This is square root of 5. Is this simplified as much as possible? Yes. So if we had it where we needed to simplify it, we have to simplify the square root first and then go ahead and add and subtract. Right now they're already simplified. The other thing I'm going to check is this is the square root of 5, and this is also a 5. Because the numbers underneath the square root sign, they are the same, I can go ahead and I can add the coefficients or the front numbers together. So I can say 3 plus 2. So 3 plus 2 is 5. And then we still have that square root of 5 at the end. So the final answer for this is 5 square roots of 5. All right, so let's look at this one. Go ahead and answer this question. So look at it, see if we can go ahead and add this together, answer the question, and then come back to me. So if we look at it again, this is square root of 7, that is simplified. Square root of 7, that is simplified as much as possible. So then we're going to go ahead and add those front numbers, the coefficients or the front numbers together. We're going to say 3 plus 9, or 6. 3 plus 6 is 9, and it's going to have the square root of 7. And so 9 square roots of 7 is our final answer. All right, example number 4. We have a square root of 6 square roots of 2 plus 3 square root of 3 minus 2 square roots of 2. So first of all, let's check them to see if they are simplified. So we have square root of 2 is simplified all the way down. Square root of 3 is simplified all the way down. And square root of 2 is also simplified all the way down. I'm also going to remind myself that just a square root of 3 is, there's one square root of 3 there. And kind of in our same example as before, we're only going to combine the square roots or the radicals that are exactly the same. So we're going to combine 6 square roots of 2 and then minus 2 square roots of 2. So 6 minus 2 is 4, and then square root of 2. And then we still have plus 1 square root of 3. So let's go ahead and look at these. This is a square root of 2. This is a square root of 3. Can I add those together? No, I cannot. So this is a weird answer, weird looking, but it is the correct answer. All right, example number 5. So again, let's go ahead and let's check and see if these are reduced all the way down. So is 8 reduced all the way down? It is not. So before we can even start anything, we need to reduce or simplify the 8 underneath the square root sign all the way down. So what we're going to do is we want to kind of think of a perfect square that we can pull out of 8. So what comes to mind for me is I can actually go ahead and kind of decompose these or make it so that 4 times 2 makes the 8. And 4 is perfect prime. meaning that if I take the square root of 4, I can get a whole number. We still have that 3 sitting on the outside, and then we still have the minus square root of 2. And the minus square root of 2 we're still going to keep there. It's not going to do anything with it. And so if we look at it, we can kind of think about it as, oh, we have 3 square root of 4 times square root of 2. And again, still minus square root of 2. So square root of 4, it's a perfect prime. Square root of 4 is 2. We are multiplying it by the coefficient, the front number, which is 3. And we still have the square root of 2. And then the minus square root of 2. 3 times 2 is 6 square roots of 2. We still have the minus square roots of 2. And remember that there's 1 kind of sitting at the end. So now let's go ahead and let's check the square roots or the radicals. This is square root of 2. This is the square root of 2. Can I combine these two together? Yes. They have the same number underneath the square root sign. So we have 6 and then negative 1. 6 minus 1 is 5, and then square root of 2. So our final answer is 5 square roots of 2. So here is some questions that you can go ahead and go through. Go and try these, see if you got them. So pause, answer these questions, and then come back to me and see if you've done them correctly. All right, these are the answers that you should have gotten. And also I showed my work as far as kind of why it actually went there. Let's go ahead and pause, go through this and see if you got the same answers. And then if you didn't, kind of the reason why. All right, let's talk about multiplication. So again, addition and subtraction have one rule. Multiplication and division kind of have the same rules. There's just in one area where it's a little bit different. With multiplication, we're going to rewrite the coefficients together and the radicands together. So the radicands are the numbers underneath the square root sign. We're going to write the prime factorization for the radicands. We're going to simplify the radicands, multiply the coefficients, and eventually simplify all the way down. So example number 1, we have square root of 5 times square root of 7. So we're going to go ahead and we're going to write these together underneath the same square root sign. So we're going to say square root of 5 times 7. Then we're going to go ahead and simplify these as much as possible. 5 is already simplified as much as possible. 7 is simplified as much as possible. So once we've simplified them all the way down, then we're going to go ahead and multiply those numbers together. So 3 times 7 is square root of 35. So can we reduce square root of 35 any further down? No, we cannot. So this is our answer. Let's go ahead and we have 4 square roots of 3. And then we have a square root of 21. So that's like 1 square root of 21. We're going to go ahead and combine our coefficients together. So we're going to say 4 times 1. And then we're going to go ahead and put the 3 and the 21 together underneath the square root sign. So I'm going to go ahead and I'm going to simplify even further the 21. So again, I want to kind of pull out a perfect prime. So I think about the perfect prime list, like 2 times 2, 3 times 3, what those actually numbers are. And I remember that 21, one of the factors of 21 is 3, right? So we're going to go ahead and we're going to simplify the 21. We're going to say 3 and then 7, okay? 4 times 1 is 4. I'm going to go ahead and I'm going to kind of combine some stuff together. See the 3 times 3? I know 3 times 3 is 9. Still, I have the times 7. So really, it's 4 square root of 9 times square root of 7. Square root of 9 is 3. So technically, I have 4 times 3 in the front times square root of 7. 4 times 3 is 12. And then we still have square root of 7. Can I reduce square root of 7 down any further? No. So 12 square root of 7 is our final answer. Here is number 3. We have 2 square roots of 15 times 3 square roots of 21. So again, we're going to take our coefficients. We're going to stick them on the outside. So we have 2 times 3. And then we're going to put the other two numbers underneath the square root sign. So we have 15 and 21. So we're going to say 2 times 3 is 6. Then we're going to factor the 15 and the 21. So 15 we know is 3 times 5. 21 is 3 times 7. I also, again, remember, so I'm looking kind of for the perfect primes list. So remember, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, right? So I'm going to go ahead and I see the 3 times 3. So I still have my 6 on the outside. Still have my square root. 3 times 3 is 9. And then we still have the times 7. And again, we can kind of rewrite it again. We still have the 6 on the outside. Square root of 9. And then times square root of 7. Square root of 9, because of the perfect squares list, is 3. So I have 6 times 3. And then still the times square root of 7. 6 times 3 is 18. So I have 18 square root of 7. Is 7 simplified all the way down? Yes, it is. So this is my final answer. Example number 4. We have 3 square roots of 12 times 6. So again, we're going to go ahead and combine our outside numbers. So the square root of 6, there's only 1 there. So I'm going to have 3 times 1. And then I'm going to have the square root of 12 times 6. 3 times 1 is 3. We have square root, and let's go ahead and let's factor 6 and 3. So if I can think about it, I do want to take out a number that on the perfect primes list, or sorry, perfect squares list. So 1 squared is 2, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, so we kind of think about it. So 12, oh, there's 4 that's on the perfect squares list. And I know that 4 can be a factor of 12. So I can actually do 4 times 3 for the 12. And then is there a number for 6 as far as the squares? No, not really. But I do know I can do 2 times 3. Let's go ahead and again kind of rearrange some stuff. I still have that 3 on the outside. I still have the square root of 4. But one of the other things I kind of notice is that we have a 3 and a 3. And I know 3 times 3 is 9. Why did I do that? It's because 9 is part of the perfect squares list. And then I still have times 2. Let's kind of bring it down even further. I have 3. We have square root of 4 times square root of 9 times square root of 2. 3 is still the same. Square root of 4 is 2. Square root of 9 is 3. Can I take the square root of 2 and get a whole number? No, so I'm going to leave it how it is. Okay? We're going to say 3 times 2 times 3. What is 3 times 2 times 3? That is 18. Square root of 2. Is there anything else I can simplify any further? No. So our answer is 18 squares of 2. Let's talk about division. So division steps are rewrite the coefficients together and the radicands, or the numbers underneath the square roots, together, each as a fraction. Write the prime factors for the radicands. Simplify the radicands by crossing out like terms. Divide the coefficient, and then eventually simplify. So we're going to go ahead and talk about that. We're going to go through some examples and talk about that. Here is example number 5. It's our first one for division, but we're working through examples. Here's example number 5. So what we're going to do is we're going to factor, well, we're actually going to look at it. So can we take the square root of 4 and get a whole number? Square root of 4 is 2, and square root of 36 is 6. Oh, that's a fraction, 2 over 6, with kind of nothing else in there. Can I reduce this any further? Is this a skinny or a fat fraction? This is a fat fraction, and it will reduce even further down to 1 over 3. Another way of looking at it is we can factor 4, which is 2 times 2. 36, we can write it as 2 times 3 and 2 times 3. So it's pretty much, it's 6 times 6, which is 2 times 3 and 2 times 3. Notice how there is a square root of 2 on the top, a square root of 2 on the bottom. I can cross those out. A square root of 2 on the top, square root of 2 on the bottom. I can cross those out. And remember, if we ever cross everything out on the top, technically what these are making, they're making ones, right? Remember, if we have the same thing divided by itself, is making a 1. So I have a 1 on the top. And then notice how the 3 times 3 makes square root of 9. And again, the square root of 9 is 3. So there's different ways of kind of looking at that, but we've done it correctly. Here is example number 6. So again, I can look at it and go, oh, square root of 4, that's 2. Okay. On the bottom, I still have 4, and then square root of 5. Can I simplify square root of 5 any further? Not really. All right. So I have 2 over 4. So 2 over 4 is a fraction. If I do 2 over 4, and I put it in my calculator, because it's a fat fraction, right? If I do 2 over 4, simplify it further, I know that is 1 over 2. And then still on the bottom part, we have square root of 5. So our answer is 1 over 2 square roots of 5. Because if we think about it as far as this part here, I have 2 on the top. Factor 4 is 2 times 2, still square roots of square roots of 5. 2 divided by 2 makes a 1. And again, notice how it's still our answer of 1 over 2 square root of 5. Different ways of looking at it, still the same answer. All right, let's go ahead and let's simplify things as much as possible. It's square root of 5 divided by square root of 45. Square root of 5, can't simplify it any further, so it stays there. Square root of 45, again, I want to see if I can pull out a number from the perfect squares list. So I know with 45, I can say 9 times square root of 5. I'm going to split those to kind of help us a little bit further. So I still have square root of 5 on the top. I have square root of 9 times square root of 5 on the bottom. Notice how I have a square root of 5 on the top, square root of 5 on the bottom. That makes a 1, right? So really I have now 1 over square root of 9. What is square root of 9? That is 3. So my final answer is 1 over 3. All right, example number 8. Let's kind of go through it again. We still have that 2 on the top. I still have a 3 on the bottom. But again, we're going to factor the square root of 18. Again, I want a number coming out of the perfect squares list. And that, I know, looking at 18, I know that 9 times 2 makes 18. Okay? I'm going to kind of rewrite it again so we look at it. We have square root of 9 times the square root of 2, and then still over 3. On the top, we still have 2. Square root of 9 is 3, so 2 times 3. Can I take the square root of 2 and get a whole number? No, that's going to stay on the top. And then on the bottom, I still have 3. Anything else I can go ahead and cross out? Well, yeah, 3 divided by 3 makes a 1. And so it's going to leave me as 2 times square roots of 2. Can I simplify square root of 2 down any further? Can I simplify anything else further? No. So our final answer is 2 square roots of 2. So here's the first part of our practice problems. Go ahead and try these. I actually have 5 of them. We're just going to kind of do them 2 at a time. So go ahead and write down these ones answer those questions. So pause, answer those questions, and then come back to me and see if you've done it correctly. All right, here are the answers and also the work to go ahead and solve those. So pause, check, and make sure you've done those correctly. And if you're not, fix what you did wrong. Here is numbers 2 and 3, 3 and 4. Go ahead, write these down, and pause, write these down, answer those, and then come back to me. All right, here is the answers and also the steps. Make sure you pause, go through this, and make sure you understand how those answers and how to get there. Last practice problem in class, number 5, square root of 12 divided by square root of 2. So go ahead and pause, answer this question, and then come back to me. All right, here is the answer and the work to go ahead along with it. Make sure you pause and understand how the answer came about. And then this is our last practice problem and the end of our notes for today. So we do have Canvas assignment. It's called add, subtract, multiply, and divide radicals. Make sure you get on there and go on through the practice problems. Hope you have a good day. Thanks. Bye.